Good afternoon, guys. So, last class we have seen that is basics of router OSI layer we have seen, and then what we have seen TCP UDP we have seen. After that, we have seen a small practical that is introduction to your Cisco packet tracer. So, how many of you installed? Everyone installed? Everyone? Okay. So, are you able to drag the router? Did you configure all the IP addresses? Comfortable? Any doubt on those things? No, this is easy. Just you can follow the video and you can do it. So from now, that is from today, every day you'll have practicals till your switching concept is over. So last two classes of CCNA will be without practicals. That is mostly theory you have. Other than that, everyday practicals is there. Okay. So try to do the practicals then and there. Try to so while I do a practical, I will ask you to do the same practicals, and then I'll give you an extra task also. So that also you can do. So once you understand and do the practicals, then the concept will become very clear. Okay. So today we are going to learn ICMP ARP Telnet SSH. What is ICMP? Internal Control Message Protocol. And what is the protocol number? 1. Okay. And then it is used for error reporting. And then it is used to check communication issue between two devices. Here you have type 0. That means echo reply. Then you have type 8. Means echo request. And your ping and trace route works on the protocol. TTL value. Okay. Value. For Linux, it is 68. Sorry, 64. And then your Windows PC. For Windows, it is 128. And then router 225. TTL means time to live. Write it down. Yeah, ICMPs are like your basics of your networking. They might ask you simple question in ICMP. What is ICMP? Then you can say it is used for error reporting. It is used to check the connectivity between devices. Your ping works on there. So whatever point I've given you here, that if you give that is enough for ICMP protocol. Okay. So in PPT, you will have a brief definition. There is no way you can exactly remember those definitions. Always try to understand the concept. What is ICMP protocol and what is the use of ICMP protocol? That if you explain like this, then you will also not forget, and then the interviewer also will feel comfortable. Okay. Sometimes when I ask the question, what are the layers of OSI? They'll keep on explaining TCP, UDP, everything. We are not expecting that. And I ask you, what are the layers of OSI? Just say physical data link network transport session presentation application. That is the question. Always answer to the question. Don't drag it. Okay. All right. So your ICMP protocol number is 1. Okay. And it used for error reporting. So once I'm not able to ping to a network, then I will know, okay, the connectivity itself not there. Okay. To check the connectivity, we are using ICMP. Okay. And here you have type 0 and type 8. Type 0 means echo reply. Okay. When you am giving your first time trying to ping from here to uh, the last last router. So I will try to ping. I am initiating it. So I will use type 8 request packet. I will use the request packet. And then he will give the reply to me. So that will be type 0, a reply packet. Okay. And your ping and trace route works on ICMP protocol. What is ping? It is used to check the connectivity, that is latency, speed. Trace route means what? So between your source and destination, how many hops are in between? That is trace route. You remember on day 1 or day 2, I said ping google.com and I said trace route google.com. Both have reached the connectivity, correct? But in between, what are the hops is there? That is trace route. Okay. And what is this TTL value means? Time to live value. That means if I'm going to ping from Linux to Linux, then that the TTL value will be 64. Maximum hop that can go up to 64. If it's Windows PC, the maximum hops it can be 128. Okay. And if I try to ping a router, that will be 225. I'll show in practicals. Okay. So this is your ICMP protocol. Now come to PPT. So ping, ICMP and ARP concepts we'll see. So how to check connectivity between two devices? That is ping. So the ping command is used to test the connectivity and latency between two network devices. What is latency means? Speed. How speed is the connectivity there? Okay. So the ping command sends packets of information to a specified IP address and then measures the time it takes to get a response from the specified computer. So I'm going to ping the R1 to R10. So it will say how much time does it takes to reach there and come back. That is your ping, the connectivity. And the ping works on ICMP protocol. So what is trace route? Trace route command is used to conduct a similar test to ping, but instead of displaying the time, it will tell you exactly how much server hops present in between your source and destination. Okay. If I'm trying to ping from here to the last person, I think Ahmad, right? If I'm trying to ping from me to Ahmad, so how many people are in between? That is trace route. What is ping? I will just see the speed, how much speed I'm getting to from me to Ahmed. That is ping. Okay. And then you have ICMP, Internet Control Message Protocol, and the protocol number is 1. So it's a network layer protocol. Why we say this as network layer protocol, guys? Why we say ICMP is a network layer protocol? Because it uses IP address. To ping a network, we are using IP address. So your IP address works on network layer. So that's why we say ICMP is a network layer protocol. Okay. And then used to network device diagnose network communication issues. So if I'm not able to ping the network, then I know the connectivity itself not there. Correct? So I'll try to check the connectivity. Is everything in between is fine or not? Okay. And ICMP is mainly used to determine whether or not data is reaching its intended destination in a timely manner. Commonly, the ICMP protocol is used on network devices such as routers. ICMP is crucial for error reporting and testing. Reason being, if I want to send a data first I should know that person is there or not. Correct. If I'm giving say for example, if I'm going to give a book to the next classroom to a student who is sitting there. Okay, I'm giving to one of a student in my class. Okay, pass the book to the specific person. What if the person itself is not there? Then what's the point of sending this person there? Correct. First, I should know that ABC person is in the next room or not. So first, what I'll do, I'll simply ask, I'll call him, are you there in the classroom? He'll say, yes, I'm there. And then I'll send the book. So book is your data. The person who I'm sending the book is the data. That person is the destination. So first I need to know that person is there or not. So that's why we are going to ping the network. First we are going to check the connectivity. Anything in your CCI, NA, NP, CCIE, whatever you're doing, first always we check the connectivity. That is your ping. Okay. And then I will send the data. All right. So this is your ICMP protocol. Okay. Next concept, your ARP, address resolution protocol. This is quite important topic. Okay. So before going to this ARP, I need to know what is default gateway. What is default gateway? What is default gateway? So default gateway is the hop that we are trying to reach outside to our network. For example, if I'm having a topology like this, who's that Lenovo? Mute yourself. So from now on, your networking classes, your CCNA class will be little more interesting because every time we are going to see the theory and we are going to perform and see the theory. It will match the theory and practicals. So you can see the output. Okay, it will be little more interesting. Not only theory. Your theory is over. First 1 week class is theory. That's it. So here I'm having three routers. This is my R1, R2, R3. Switch 1, switch 2, and switch 3. This is PC 1, 2, 3, 4, and 5, 6. Okay. So one interface of router is one network. So this is one network. Correct. One network. This is another network. Two network. This is another network. Three network. So between this router to this router, this is another network. Four network. And here to here, it is fifth network. Okay. So we have five networks in this topology. So for this router, for PC 1 and 2, if one has to communicate with 2, he will communicate directly like this. He will go to switch and he will communicate like this. And the 2, if he wants to speak to 1, he'll go like this. Correct. There is no need for him to go out. Correct. If PC1 if PC1 has to communicate with PC3, then what will happen? Then he has to go out, right? He has to go to this fifth network and then he will be able to reach this 2 network. So in this case, what is required? Your routing is required. When you try to communicate with different network, then routing is required. Okay. But before routing, how he will go out? Till switch, he'll come to the packet will come like this to switch. Again, it will go like this. So this interface is right. This is the interface. He will go out. So this is the default gateway. Okay. So if I'm sitting in the classroom, that is second floor. If I have to go to third floor, which is in different network, how I will go? Through that door. Correct. So that door inside only you will open. Correct. How you will be able to open outside? No, right? You will not have the access to open outside. The inside knob, you will open it and you'll go out. That inside knob is your default gateway. Okay, same like this. For this network, this interface is the default gateway. The interface which is connected to the router is called the default gateway. And through that default gateway only, every package will go out. Okay. And for this one, this interface will be the default gateway. Because he has no idea about this interface. This is what? Inside network. That is LAN network. This is outside. The other interface is outside. Here for this 2 network, R2 will the PC3 and 4 will understand this interface, not this interface, because this is in different network. They will not know it. Okay. The interface which is connected directly to the router is called the default gateway, and through that default gateway, they will be able to go outside the network. Okay. All right. And then we have ARP. What is ARP? So the address resolution protocol is a communication protocol used to discover data link layer address. That means what? It is used to identify the data link address means MAC address. Associated with internet layer address means your IP address. Correct. So come to the same topology. Or I'll draw another topology. So this is 10.1.1.1, 10.1.1.2, 10.1.3. Okay. So a packet will be generated. ICMP packet will be generated and he will send it to switch. Correct. But does this router know who is 10.2 and 10.3? He knows there is someone called 10.2 and 10.3, but he doesn't know who exactly is. For that, he needs to know the MAC address. Correct. He has a MAC address A, he has MAC address B. What is the hexadecimal value of B? I mean, decimal value of B? 11. So he will be able to identify by B only. So he has to resolve this MAC address and this MAC address. If he's saying ping, in router I'm giving pin 10.1.1.3. Okay, then he has to resolve this B MAC address. Then only he will identify, okay, he is 10.3, not him. How I'm going to identify? By resolving the MAC address. Who is going to resolve the MAC address for me? My ARP, address resolution protocol. It is used to map IP using MAC address. We'll see the practicals also. See here. So ARP is a request response or reply request protocol in which one device sends a request to another device asking for some information, to which the other device will reply with required information. It is the message exchange pattern. Our packets are encapsulated with link layer or a distribution. Okay, we'll come to this once we do the practicals and then we'll come and see this. So I'll take two PCs first initially. How I'm going to connect? How I'm going to connect means here you see this flash symbol, right? Connections, click on this. And here this is what? Automatic choose connection pattern. Can you see here? Automatically choose connection type. So control or just normally click on this, click on the PC and click on the PC. Okay, for example, if I have multiple devices, so multiple laptops like this. Okay, how I will connect it? Go to this connections. Here you have this control, click on this, click, again click on this. We have only one port connected to that port. Okay, connect here. I'll take a router. Only one port you can connect, right? If you are having like this, go to this connections, click control, click on this one, click and drag it. Click and click on this router. Click and click on this router. Like this, you can do the connections. Okay. So how I'm going to assign IP in PC? Yesterday we have seen how to assign IP in router. Today we'll see PC. PC is very simple. Click on this PC. Here you have desktop. Go to desktop. Okay. And then you have IP config. Click on this IP config. What is the IP address I'm giving? 10.1.1.1. Okay. Subnet mask I'll give 255.255.255.0. Default gateway I don't have to give because they're directly connected. Okay, if they're going outside the network, then default gateway is required. So I'll just skip that part for now. Now for this PC, I will give 10.1.1.2, 255.255.0. Done. So they are directly connected. Okay. If I give ping 10.1.1.2, will he ping? He will ping. But does he know the MAC address? This PC0 will know the MAC address of PC1 or not? No. Though they are directly connected, there is no communication happened before. So they will not know the MAC address. So initially what will happen is he will generate a packet, ICMP packet. Okay. And then in that ICMP packet, MAC address will not be there. So to resolve the MAC address, ARP will come in picture. See, I'll show in simulation part. Okay, now I'm going to click enter. See, two packets are generated. Can you see? Two packets. What is the first packet that is generated? ICMP. Click on this. IP address is source IP is 10.1.1.1 and destination IP is 10.1.1.2. And what is the message type? 8. 8 means what? What I've given you? Echo request. Because he is trying to ping here. Correct. So that's why you see it as 8. Okay. But problem is he doesn't have what? MAC address. So that's why to resolve the MAC address, your ARP packet come into picture. Okay. Initially, if we try to ping, echo request will be generated. ARP packet will not be generated first. Always your echo request packet will be generated to resolve the MAC address. Then your ARP packet will come into picture. Okay. This is your ARP packet. Click on this ARP packet. So what is the source MAC of this PC? 00D0. And destination MAC he doesn't know. That's why you see FFFFF means broadcast. He is just simply going to broadcast that packet to identify who is 10.1.1.2. He will ask. See. Now I will send this packet. Your R packet has went from this PC to this PC. Now click on this PC. So this is the message which came earlier. 00D0 was broadcasted. And 10.1.1.1 source IP, 10.1.1.2 destination IP. Now in the packet which is going to be replayed to PC0 is C. Source IP has become 10.1.1.2. Destination IP has become 10.1.1. Now he is going to replay it with his MAC address 0001, saying this is my MAC address. And destination MAC address is 00D0. See, now the packet, he will send it back. Packet is sent. Now the ARP is what? It says tick. It means what? The MAC address has been resolved and ICMP packet come into first. Because ARP work is done. Now click on this ICMP packet. You have the source MAC that is 00D0 and destination MAC 0001. Correct? Source IP also he knows. Destination IP knows. Source MAC, destination MAC. Now everything is fine. Now packet has come here. What packet came? Type 8 packet, echo request. And what packet is going to go now? Type 0. That means what? Echo replay. So echo replay packet will go back. Type 08 means request, 0 means replay. Here source is 10.1, here destination is 10.1. Here destination is 10.2, here source has become 1.2, 10.1.1.2. Okay. Now see, you will send it. How many packet went? 1. Again click. 2. 3. 4. And that's it. Even if I click, it will not work because PC will send only 4 packets. Your router will send 5 packets. So 4 packets are done. Now go to real time. Now click on this PC. You see this 4 replays. This is the first packet which I sent. Second packet, third packet, and fourth packet. What is the TTL value here? 128 means Windows PC, the maximum is 128. That's why you see it as 128 and successful is 100%. So this is how your backend, your ARP and ICMP works. Simply when I say ping, immediately you get the replay. Correct? See, for example, I'll say 1.1.1.1 default subnet mask. 1.1.1.2 default subnet mask. I'll simply go here and I'll say ping 1.1.1.1. See, within a second you're getting the reply. But before this reply, what happens? Whatever we seen earlier. That is the backend process. First, type 8. So they will ask you if I'm trying to ping from my source to destination, which are connected in same network. So what will be the backend process? This might be your interview question. So how you're going to answer it? When I try to ping with my source to destination, which are in same subnet, first initially the ICMP echo request packet will be generated. That is type 8. Okay. I will not have the destination MAC address, so that to resolve that, my ARP packet will come into picture. Okay. So my ARP will be sent as a broadcast to devices connected in the network and to resolve the MAC address of that particular destination. And he will reply with his MAC address. Okay. Now the ICMP packet will be with source IP, destination IP, source MAC, and also destination MAC. Now I will be able to ping from my source to destination. This should be your answer. Neat and simple. Explain the concept. Okay. So this is how you should be able to answer. Any doubt on this?
Sir, in this we are wanting to find the destination MAC address now.
Correct.
For that, first we are sending ICMP packet.
No, we are not sending ICMP packet. How we will send ICMP packet? Without MAC address, you can't send ICMP.
Destination MAC address is not there, so we will send that ARP packet.
Correct.
But it is generated simultaneously.
Yes, it will be generated. First, request packet will be generated. See, for the first time I'm trying to ping, ARP packet is generated. Next time it will not generate because he already knows the MAC address. Why he will generate ARP? For the first time it is going to generate, not every time.
Okay. For that is for finding the destination MAC address, we are sending this ARP packet,
Correct.
right?
Correct.
Like that.
Correct.
Then after getting that, we will send ICMP like
Directly.
here and.
So next time the ICMP request will be generated and directly they will go. Okay.
Okay.
Not in buffer. He will not have the details. So he will simply stay there only. Buffer means what? He is waiting to go. Okay. This one, he does not have the exact address. See, if I say, for example, I'm saying, okay, HSR, 5th Main, Sector 6, Bangalore. Okay. You don't have the door number. Is it easy to find which one in Sector 6? Sector 6 is very big. 5th Main is a long road that is almost a 2-kilometer road. How you are going to find? So he'll simply stay. Once I resolve the door number and give you door number is network as home, door number 5 or whatever, then directly you will go there. So he'll simply stay there without the details. Okay. So this is your ARP works. All right. Any doubt? Online guys, offline? So your task, same thing. What you're going to do? Take 2 PCs. Okay. And then assign the IP address. Change the IP address. Change it like 172.16.15.1, 172.16.15.2. And what you're going to do is write down first. Write down ICMP like this. See. First, what packet is generated? ICMP packet. ICMP. Correct? You have source IP, destination IP, source MAC, and then destination MAC. Okay. So capture the packet and write down what is the source IP, destination IP, source MAC, and destination MAC. Okay. Then you have ARP packet. In your ARP, you will have again source MAC and destination MAC. Correct? Write down this while it was requesting. Again, it will go to PC2. In PC2, same way you can write destination MAC, source MAC, whatever it is. And see the differences. So initially it will be what? FFFFF here. Here it will be 0001, whatever the MAC address is. But once it goes to other side, source MAC will become 0002, whatever the MAC address of that PC. And then the destination MAC will become 0001. Okay. It's not simply doing the practicals. You have to understand it. If you can do this and write it down, and if you can understand the verification, then the concept will never forget. Okay, all right. Now come to PPT. So now learn. ARP is a request response or request replay protocol in which one device sends a request to another device asking for some information. That means what? He is going to send a thing to other device for MAC address. He is requesting for MAC address and he is going to replay the MAC address. Okay. To which other device will reply with the required information. So the PC1 will send this own MAC address to the PC0. Okay. It is a message exchange pattern. Our packets are encapsulated by link layer and are distributed only in particular network. So within the network only it works. ARP. It is not going to go outside the network. Within the network only it works. As a result, ARP is said to be the link layer protocol. Okay, that's why we say ARP is a link layer protocol. Within the network only it works. This is your ARP. Then this is your ICMP header, guys. Here you have source MAC, destination MAC. So you have type field. What is the type field means? Is it a request packet or replay packet? That you can see. And then you have source IP, destination IP, and what is the protocol number. These things you have in your ICMP packet. Okay. And this is your ARP packet. In ARP packet, you have source MAC, destination MAC, and you have type field. In the type field, it will say 01. 01 means request. 02 means reply. Okay. Type field, you have two type field. And then you have source IP and destination IP also. This is your ARP packet. There you have type field. Here also you have type field. Here it is request, type 0 or type 8. Here it is opcode. That is 01 or 02. 01 means request, 02 means reply. Okay. First, initially, your Ethernet header will be there. So here, see, source MAC, destination MAC, source IP, destination IP is the ARP header. Okay. Before that, there will be Ethernet header. There you will have source MAC, destination MAC, and have your type field. Here it will say 01. That means what? If he is requesting it. See, I'll show you. The two packets are generated, right? Click on this ARP packet, go to outbound P. See, Ethernet header. Sorry, this is your frame header. Here you can see, in ARP header, you can see 0001. That means what? It is trying to do the request. Now see. Here you can see opcode 0001. Now see, I will send the packet. Now click on this packet. Outbound. Here it has become 0002. That means what? While it is going to reply it. Initially it was 01. Now it is 02. This is your ARP header. Okay. So this is done. Okay. So ARP works within the network. What if my destination is in different network? What if my destination is in different network? How I'm going to ping? For example, I have a scenario like this. I have a router. Here I have a switch. I'm connected with two PCs. And here I have another switch. Here I have two PCs connected like this. Okay, we have a scenario like this. If I'm trying to ping from this source, this is PC 1, 2, 3, and 4. If I'm trying to ping from 1 to 4, which is in different network, right? This is one network, this is another network. Then what will happen? Then you have another concept called proxy ARP. What is proxy? Just simply say what is proxy. What is proxy? Don't worry about IP address. I'm not asking for networking term. Simply say what is proxy. Don't say I don't want networking term. Simply explain me what is proxy. Where we're using proxy.
So proxy is like that someone is not present, but we mark attendance for that.
Mark attendance for that. Okay, not exactly. Okay.
We are
So
showing someone instead of us if we are not there representing us.
okay, correct. That means my job is to take the class. Okay, if I'm taking off, okay, then I'm making someone to take the class instead of me. So that person is proxy. So what the other guy said is, if the guy is not present in the class, what we are doing? We are changing the voice. Say, present sir. Yeah, we do that. That is also proxy. Okay. And then there is one of my friends. Okay, they were twins. Okay, one guy is very good in academics. Other guy is rubbish. So he used to make the other guy to go and write the exam. Okay. They're twins, so they never found. Every exam, the brother used to write it. He doesn't know anything. So that is proxy. Okay. It's unlucky we have not born as twins. All right. So that is proxy. So in your coming to your networking, how this proxy works? This is very important. Okay. Pay attention. If you have doubt, then and there stop me. Don't wait for complete topic to over and then ask, sir, I didn't understand. That doesn't make sense. So here I'm having two networks, correct? This is one network, this is another network. Here I will say 10.1.1.0/24. Here 11.1.1.0/24. So here I'll give IP 10.1.1.20. Okay. This side I will, sorry. This side I'll give 10.1.1.20. Here I will give 11.1.1. Sorry, 10 I will give. Better. Easy to understand. Why make it complicated? Then here I will say 20. So here IP will be 10.1, 10.2, 10.3, sorry, 11.1, 11.2, 10.1, 10.2. Here 10.10, 11.20 I'm giving. So this is the IP address I'm going to give. So if I want to ping from this PC6 to PC8, which is in different network, then your proxy ARP will come into picture. What is proxy ARP means? Instead of this PC, this router is going to resolve the MAC address of this PC and he is going to reply to this PC. Okay, so here this PC will not come into picture because it is in different network. This PC can't go outside the network because he is an end device. So you need a router to communicate with different device. So that router will resolve the MAC address instead of the PC. So that is called your proxy ARP. Okay, and this router is going to resolve the MAC address of the other PC which is in different network, and he is going to give his own MAC address. He is going to give his own MAC address. In practical, it will become clear for you. Okay. First, initially what I'll do, I'll assign all the IPs. Okay. I will take only 2 PCs. I don't want to make it complicated for you. First, understand this. So here I will take 10.1.1.1. 10.1.1.1 /24. Okay. The real time. 10.1.1. Okay. So what is the default gateway here? 10.1.1.10, because through this way only he will go out. Okay, that's why I'm giving 10.1.1.10. And I will change the MAC address also. See, you can't change the MAC address. To understanding purpose, I'm changing it. Okay. Now here I will assign IP address. Go to desktop IP config 11.1.1.1. 11.1.1.20. Go to config first Ethernet. I'll change the MAC address as 2. Okay. Done. Now go to your router. No. Enable. And then you give configure terminal. Hostname R1. Interface gig0/0. Where is gig0/0? Ooh. Wait. Interface is off. So I'll make both the interface on. No shut. Interface gig0/1. No shut. Go to this. Go CDP neighbor. Okay. 0/1 it is connected. Okay. So this switch is connected to 0/1. Okay. If I do like this, you can see. Now you can see 0/1 this side, 0/0 on this side. Okay.
Sir, what command you typed to see that?
Show CDP neighbor. This again I will teach you in upcoming classes.
So CDP neighbor.
Yes. So here I have given interface gig0/1. Okay. IP address what I'm going to add? 10.1.1.10. 0. No set I've already given, but still I'll give. Okay, now I'll do ping 10.1.1. No, I'll not ping. Because to resolve the MAC address, I don't want to ping it. So I will also say MAC address is I've changed it to 10. Okay. See, you can't change the MAC address. For the understanding purpose, I'm changing it. Okay. Interface gig0/0. What is the IP? 11.1.1.20. Okay. No shut. And then MAC address, I will change it to 20. Done. Okay. Oh. Now simply go and say do show IP interface brief. So 0/0 11.20 is there. 0/1 10.10 is there. Fine. Status is up. Everything is fine. Now assigning of IP address is done. Now let's see how it is going to resolve the MAC address of the PC which is in different network. Okay. ARP and ICMP packet I'll capture. So I'll say ping 11.1.1.1, right? 1 I've given here. I'll give enter. How many packets generated? 2. What is the first packet? ICMP. And then to resolve the MAC address. So here it doesn't have the MAC address. So that's why your R packet is generated. Okay. So R packet is, what is the source IP? 0001. Select it. So destination IP is 10, source IP is 10.1. Destination IP is 10.10. But what ping I've given? 11.1. But what is the source IP here? Destination IP here? 10.10. But initially it is trying to resolve the default gateway's MAC address. Though I've given ping 11.1.1.1, the destination IP here it is what? 10.1.1.10. Because first of all, he has to know where is the gate. If I have to go to third floor, first I have to find the door inside my class, right? Then only I can go out. I don't know if I don't know if the door is not there. If I'm blind, I've covered my eyes, okay, blindfolded. So what I'll do, I'll simply search for the gate door and then I'll go out. So to find the default gateway, it is going to resolve the default gateway's MAC address first. So that's why you see it as 10.1.1.10. Okay. And the destination MAC is what? FFF, because it doesn't know. Source MAC is 01. So here I've given source MAC 01. Here the MAC is 0001. Here 2 I've given. Here 10. Here 20. Okay. Now this is the thing. Okay. Now I will simply send the packet. So your R packet has reached your router. So here it is going to reply with its own MAC address 0010. Okay, the router is going to reply with its own MAC address. This is the packet initially came 10.1, 10.10. Here source has become 10.10. Destination will become 10.1. And source MAC is 10 and destination MAC is 1. Now see. The packet will come here. Now ICMP packet will come into picture. ICMP packet has came before. Now see. Your ICMP packet will go to your router. And what it will happen? It will drop. It will get dropped. Why it is getting dropped? Because that is not the destination I want to ping. I want to ping to 11.1. So from here, again, this R packet will be generated here. Because you want to resolve it to the other network device. Now click on this R packet. Now sources become 20. That means this side of the interface will resolve it. So that's why you see source IP as 11.1.1.20 and destination IP as 11.1.1.1. Okay. And source MAC has become 20 and destination MAC he doesn't know. Correct. So initially it came to here. Initially I tried to ping from here to here. So the packet went here. He got the MAC address of this default gateway. Again, he replied back here. Correct. And then he tried to ping this default gateway. The ICMP packet went, it got dropped because that is not the intended PC he wants to ping. Okay. Again, to resolve this MAC address, this interface will forward the packet to the other side of the interface, 11.20. Okay. So that's why you see 11.20's MAC address. But 11.20 will not know the MAC address of PC9. Okay. So that's why you see FFFF means he is going to broadcast within his network. Okay. Any doubt as of now? Okay. Now I'll send this packet. Now packet has come here. Now click on this packet. Now this is the packet which came in earlier. Correct. 20 source IP is 11.20 and destination IP is 11.1. Now 11.1 is going to reply. Source IP has become 11.1. Destination IP has become 11.20 and source MAC he is going to reply with its own MAC 0002 to the destination MAC 0020. So he will send it to his interface only. He doesn't know who is the 10. He will send it to his own gateway, his own default gateway. Who is the default gateway of PC? This PC9. This side 11.20. Okay. Now send the packet. So packet has reached here. Correct. Now click on this packet. So now this router has the default gateway of the MAC address of the destination 11.1, that is 0002. So source IP is what? 11.1. Destination IP is 11.20. Now see. Now the packet has came here. So your ICMP packet is here. This router has sent the ARP packet to this packet. So now this PC will have source IP is 10.1.1. Destination IP has become 11.1.1.1. But initially, in your ICMP echo request, what was the IP? Destination IP? What is IP? Tell me the IP. What? No. What was the initial destination IP? 10.1.1.10. Correct, because he was trying to resolve the default gateway's MAC address. Now he has resolved the default gateway's MAC address. Now he has 11.1.1.20. So message type is what? 8. Source MAC is 0001. And destination MAC you can see 0010. You don't see 0002. Because what is proxy ARP? The default gateway is going to resolve the MAC address of the PC which is in different network and give its own MAC address. That's why you see 10 here. But default destination IP is 11.1.1.1. But this side it should be 0002, right? But it is 0010. That is default gateway's MAC address. So the default gateway is the one who is going to resolve and send the packet. So that's why we call it as proxy ARP. Instead of this PC doing the work, the router is going to do the work. Now let's send the packet. Now click on this packet. So this is the message which came earlier. Now in this side, destination source IP, destination IP is same, but you can see from 11.20 is going to send it to 11.1. Still type 8 because packet haven't reached here. Now packet has reached here. Now click on this packet. It will become type 0. So this is the inbound PDU which came earlier, type 8 request. Now he is going to reply it. What is the reply? Type 0. Now send it back. Click. You can see source is what? 10 only, not 2. It will always give its own MAC address. Default gateway will give its own MAC address. Packet has came and it will say tick. It is successful now. Now again we'll send. Again we'll send it back. Okay. Again successful. Again I will send it. Came. Same process will repeat. Now they have the information. And it is tick. Done. I can't send no more. Okay. Now go to your real time. Close this simulation panel. Ooh. Okay. Now go to real time. Now click on this PC. Here you can see 4 packets are sent. Correct? Received only 3. One is lost. 25% lost. That is first packet got dropped. Request timeout means it has got dropped. Why? The first time when the packet went here, it got dropped. You remember? Because he was trying to resolve the MAC address of default gateway and he was trying to ping the default gateway. But that is not my destination. I want to ping the different network. Correct? So that's why the first packet will always get dropped if you try to ping for the first time when your destination is in different network. Okay. But next time when you ping, you will not have that first packet getting dropped because they already know the MAC address. Simply he will forward it. Okay, this is your proxy ARP. Okay, I know. See, initially it will be like little different because you are going to see whatever happening in background. You have to do at least 2-3 times of practicals of this. So first time, what you're going to do, take the same topology, arrange it like this, whatever I'm doing, change the MAC address. I'll give you the commands also now. Okay, you can change the MAC address. Perform same thing. Okay, if possible, take your mobile, play a recording in your mobile, and with me itself, you can do the practical. First, for the first time. Second time, do it without seeing the recording. Third time, you're going to change the IPs. You're going to change the MAC address. Instead of 01, you can take 05. Here take 06. Here you take 0110. Here take 0220. And then every packet you capture and write down it. Okay, write down what is the source IP, destination IP, source MAC, destination MAC, how it is changing, where it is FFF, where it is resolving the MAC address. Okay, how it is changing. Then you will understand the concept. Okay, because if they ask you technically on topics such as proxy ARP and ARP, you will get problem. If they ask you definition, you will be able to say it is used to, resolve the MAC address of the IP which is in different network, and it is going to give the same MAC address. Simple. You will save it. You'll say it. What if they give a scenario? The question might be like this. So if you come to interview with me, I will ask a question like this. So I have a scenario like this. Okay. Here I have a packet. Here I have a switch. And here I have a PC. Okay. So this PC is trying to send this PC. And IP is, I will say, 111.111.111.112. Here it is 10.1.1.2. Okay. So when the packet comes here, at this side, what will be the source MAC and destination MAC? Like this, they may ask a question if they want to dig you deep. Okay. If you understand the concept, very simple. The MAC address of this interface and destination MAC address will be this PC's MAC address. What will be the replay packet? You can say simply, this will become source and this will become destination MAC. How you will be able to answer? Only if you do the practicals and understand the concept. Okay. Watch the recording again. Okay. And again, watch the recording and do the practical. First, watch it completely. Then do the practical. Then again, do the practical without seeing the recording. And third time, you're going to do with different IPs. Okay. Only if you put a lot of hard work, then only you will understand the concepts. Now you will feel like, okay, I understood. After a week or 10 days, you will not. Okay. Any doubt on this online, offline case? All clear? Online? Yes, yes. Okay. Good. So we have this inverse ARP and reverse ARP, but we don't use that concept anymore. Okay. And there is another thing called gratuitous ARP that I will teach you while we are seeing the DHCP. Okay. Then I will teach you DHCP. It is used to, GRP is used to detect the duplicate IP. Duplicate IP present in the network. For that purpose, we are using GR. While we are seeing DHCP, I will explain. Okay. Done. Getting too technical, huh? Good only, no? So here you have GR. This we'll see later. And in your ping, you also write down like this. Here, dot means uh, request timeout. Request timeout. And exclamation means successful. And then you have U, that means destination host unreachable. Write down these three things. Written? Okay. Tomorrow I'll take you to lab. Okay. So make sure you come. I'll take you to lab and I'll show you how to get access of routers and how to assign whatever it is. Okay. All right. Now we'll learn Telnet. We're going to learn Telnet. Before that, you have this default gateway. So same thing, default gateway is used for communicating to other networking host. So when the destination is in different host, then you need default gateway. Then you have proxy ARP. What is proxy ARP? Proxy ARP is used to facilitate ARP exchange in order to resolve IP address to MAC address in the device that are separated by routers in the same network or sub network. If there is a router in between, then that becomes a different network or sub network. In that case, your proxy ARP comes into picture. So routers cannot forward layer 2 packets and hence ARP messages are never propagated outside of their network. When a device wants to resolve the MAC address of another device in the different subnet, the router located in between the two subnet acts as a proxy for the other device and responds to the ARP broadcast with its own MAC address. Okay, now you understood. So here they will give you in a very, deep definition, like big definition they will give you. In simple, you have to understand like this. My PC is in different network, destination is in different PC. So the router in between is going to act as that is my default router is going to act as the proxy router as the proxy ARP. Okay. And it will resolve the MAC address of the destination IP and give its own MAC address. Resolve the MAC address of destination PC and give its own MAC address. This much is enough. The same thing they have given here. Once you read, you open the PPT and read, but it in a detailed manner. Okay. Now we will learn Telnet. It is used for remote access, and uses port number 23. So remote access, and it is in plain text, unsecure. Done. Now come to PPT. Here you have Telnet. So Telnet stands for Terminal Network. It is used as the standard TCP/IP protocol for virtual terminal service, which is given by ISO. Computer which starts connection is known as the local computer. Computer which is being connected is known as the remote computer. So here I'm going to take the access of different device. Okay, that is I'm sitting in this room, and if I take a router which is in third floor, that is what remote access. So I will be known as the local computer. The router which I'm going to connect to will be known as the remote device or remote computer. Okay. So when the connection is established between local and remote computer during telnet operation, whatever that is being performed on the remote computer will be displayed on the local computer. That means that router complete access I will get from my local device, from my device. So I'll be able to access the router which is in third floor on my screen. So that screen will come into my screen. Whatever I perform in my computer here, that will execute in the router. Okay. So Telnet operates on client server principle. So local computer uses Telnet client program and the remote computer uses server program. So I'll be the client. I will request it. He will give the information. If there is a username and password, we'll match all the details and he will give the access to me. Okay, we'll do the practicals, then it will become clear. So key points to remember about Telnet. Telnet is a application layer protocol and allows, I've already given in the notes, and allows the user to connect to an account on another remote machine. Works on port number 23 and it was designated specifically for local area networks. That means within a network we are using this, not outside the network, because it is not secure. Why it is not secure, I'll show you. So Telnet is standard TCP/IP protocol for virtual terminal service. That means what? Remote access we are taking. Okay, Sandeep, right? Your name? Feeling sleepy? What you ate? Lunch? Biryani? Huh? What rice? Egg rice. Normal. PG or outside did you eat? Is it tasty? Still, it's not tasty. Still, you're feeling sleepy. What if it's tasty? You also. PG, feeling sleepy? I know. Say, if you sleep, you're the entertainment for that day's class. I will use your name and your name only completely. What is your name? Satish and Sandeep will be the entertainment for today's class. If you feel sleepy, go drink water and come. If you sleep, every example I will use your name. That too, if you're an introvert, you're done. Okay? All right. I know this. See, the difficult batch is 2 to 4. Correct? Because you will wake up 10, 11. Correct? Because why? 2 to 4 you will finish class. Go to PG or home. You'll do all the work. At night you will use Instagram, movie, Netflix, whatever it is. Because next day 2 o'clock only class, right? We have all time. So till 1, 2, some people will chat to girlfriends. Correct? Correct, Nibin. Chat with girlfriends. Dinesh, see, Dinesh is laughing. That means he has 2, 3 channels. So after that, you'll directly go eat breakfast, if not directly lunch. Full meals you will eat in PG. Then come here. Correct? AC is on. Nice atmosphere. I'll be singing networking. Huh? I'll keep on singing. You guys can keep on sleeping. See, online guys know that to 2 to 4 batch, they will sit on bed. I'm telling you. They'll keep the laptop like this and they'll watch the class. That advantage they have. Correct, online guys? All right. Online guys are sleeping already. Very nice.
No, sir.
No. Okay. Very fast reply.
We'll feel sleepy, but we'll wash face if you want.
Wow. Feeling sleepy. Very good.
Yes.
See, if you're feeling sleepy, have a small coffee and come. That helps. Okay. Drink a coffee, black coffee or something. Eat a carrot or something, cucumber or something, so that you don't feel sleepy. Okay, don't mix something else and come. Only coffee. If you mix something else, even if you feel like not to sleep, you will sleep. Okay? What, Mohammed, right? No. All right. Now we'll get into networking. So key points to remember about Telnet. So Telnet transfers the data in plain text. What text? Plain text. So what is plain text means? If I'm going to give a password, that is not going to be encrypted. So yesterday you remember I said enable password 123. When I said show running configuration, you can see password 123. But when I give secret, then it was encrypted. So in your Telnet, you will see the password. So if I try to send the packet from this network to other network, they will capture the packet and they will see the password. That I will show you. Okay. And Telnet is vulnerable to security attacks because it is not secure. And no privileges are provided for the user's authentication. Okay. Privilege level you can give, but for authentication purpose, we can't give. Okay. So required low bandwidth usage. Why? Because it is low bandwidth usage. Once I explain SSH, you will clearly understand. Because SSH has a lot of criteria and conditions to match. But Telnet is not like this. Okay. And used in Linux and Windows operating system. Okay. Now we'll do the practicals. So, I'll give the IPs. One dot one dot one dot one and default gateway 1.1.1.10 LD. Okay. So here, say 1.1.1.2 1.1.1.10. CLI, no, enable, configure terminal, hostname R1, interface gig 0/0, IP address, and giving 1.1.1.10. No shadow. Done. Now try to ping from this network to check the connectivity. Ping 1.1.1.10. Why? I think we have given the wrong subnet mask. 255.0.0. Correct only. Correct. Okay. Try to ping again. Now it is pinging. Sometimes you have this bug in packet tracer. If you try to ping again, it will ping. Okay. Now we have the connectivity. So check the connectivity. Now I'm going to do the telnet configuration. First, initially what I'm going to say is line VTY, virtual terminal line I'm going to create. Okay. Give question mark. You can see 0 to 15. That means 16 PCs maximum can access the remote router. At a time, 16 PCs can give. So if I say 7, that is 0 to 6. If I say 4, that is 0 to 3. So here I wanted to give 2 PCs, but still I will say 0 to 3 simply. That means 4 PCs can access the router at a time. Enter. Okay. And then I've said line VTY 0 to 3. And I'm going to give the password. 1, 2, 3 I will give. Enter. And I will say login. That means I'm applying this password on the virtual terminal. Login. Enter. Done. Okay. Now go to this PC and you say telnet 1.1.1.10. See, it is asking for password. What is the password? 1, 2, 3, right? Go to the simulation. Show all or none. Edit filters. Capture telnet. Where is telnet? Is here. Capture the telnet. Go to this PC. What is the password? 1, 2, 3. 3 packets are generated. See, correct? Three packets here. Click on this packet. Go to outbound PDU details. And here you can see what is the first one? 1. Go to outbound PDUs. 2. Outbound PDU details. 3. So password you can able to capture. What if I'm sending to other device, other network? So in that PC, they will simply go and capture the packet and they will be able to see the password. So that's why it is unsecure. Data is in plain text. Okay. Now come to real time. Click on this. 1, 2, 3, enter. Now see, what does it say? R1. That means I got the access of the router from my own PC. Give question mark. So these many commands you will be able to do it. Okay, from here I can ping R2 also. So ping 1.1.1.2. See, I'm pinging from this router to this PC. Correct. But I'm sitting in PC1. I'm pinging from router to PC2. Okay, these kind of things you will be able to do it in your router. By default, the privilege level is 1. What is the privilege level means? 0 to 15. 15 means max. By default, it is in 1. We can increase the privilege level also. That also I'll show you. Okay. Before that, this is 1. Now, how to come out? Just say exit. You will come to your own command prompt line. Okay. How I will remove it? Say no line VTY, or just say line VTY 0 to 3. No password 1, 2, 3. No login. Done. Now try to take the access. Now, sometimes we have this bug, but device 0 to 3. We have this bug, but it will not work. Okay, in packet traces, sometimes we have this problem. Now I'll show you how to take with username and password and set the privilege level. Okay, what you're going to do? First, you're going to say the username. So username, I will say CCNA. Okay, then give question mark, you have privilege and password. So I'll say privilege, I'll say 15. Maximum privilege I'm going to give. Okay, and then password, I'm saying 1, 2, 3, 4. Okay, enter. Now again, I'll create line VTY 0 to 5. 0 to 5. Okay, and then login local. Here I'm going to say login local because the username and now I have username. So that is created in my local database. That's why I say login local. Whereas initially I did not create any username. That's why I directly said login. Now I'm saying login local because this username is created in my local database. So login local. Give enter. And then now come to this PC. Ping 1.1.1.10. First check the connectivity. And then say Telnet. Username is what? CCNA. Enter. Password is 1, 2, 3, 4. Enter. Now you can see directly it is in privilege mode. Correct. So here I can give configure terminal. I say do show interface, do show IP interface brief. Now I can see the these things and all, and I can say interface gig 0/1 IP address, say 12.1.1.1 255.255.255.0.0 no shutdown. That means complete control of the IP. I mean, the router is there in my PC. So what they will do, a manager will have the 15 privilege, but to the L1 employees, they will give 5, 6 privilege so that they can only monitor it. They will be able to handle only the execution mode, not the global mode. How I will exit, and I'll come to my command prompt line. So they will create multiple username password and they will give you the username password of whatever you're supposed to do it. Okay. Like this, they will do the practicals. This is your Telnet. This is by creating password. Any doubt on this? So this is what? This is the normal Telnet, that is without the password, sorry, without username, just to take the access. If you want to set privilege and all, then this is the command. Okay, write it down quickly. And how you will get the access? Say telnet 10.1.1.10. Okay.
Sir, why we use that line VTY? Can you say about that line VTY?
Yeah, line VTY means what? We are creating a virtual terminal line. So in the virtual terminal line only, we are giving the password, everything, so that you will be able to get the virtual terminal access.
03 means
03
free
means
use.
that is the range. So up to 16 PCs can use. I'm giving 0 to 3 means 4 PCs can use. I want to use only 2 means then what I'll do? 0 to 1 I can give. So
0
that
to
2
1.
PCs can use. According to our need, I'm giving. Simply I'm giving 0 to 5.
Range.
Other PCs, if I connect, then they will be able to do it. If I'm giving 0 to 2, how many PCs I can use? 3.
3.
So I have 3 PCs. So after some time, if I'm going to add 2 more PCs in my network, then what I'll do? Simply I can give the username and password and they will be able to use it. If I give 0 to 4 or something. If I'm giving 0 to 4, 5 PCs can use. Initially 3 PCs are in my network. In future I'm going to add 2 more. Then still they will be able to do it. That's why. According to our need, we are going to give it. Okay, quickly write.
And sir, the privilege we should set to 15.
No, by default, your privilege level is 1.
1.
Okay. And the range is 0 to 15. I have given 15. 15 is what? At most.
At most.
At
If you
most.
don't give any privilege, also it will work, right?
Yes, it will work, but it will take privilege as 1.
1 default.
That is default. Only user execution mode you can use.
Hmm.
Oh, sorry. Yeah, write it down. Your feedback session, I think next week they will take, it seems. Not sure. Written, guys? Yes. Written. You.
Yes, sir. Written.
All right. Now SSH. So did we learn this? Still not. Okay. SSH. SSH means secure shell and it works on port number 22. It is more secure. More secure. And then data is encrypted. Data is encrypted. And it is used for remote access. Okay. And there are some conditions, guys, here. to create SSH. It's not like Telnet. So what are the conditions means? First one, host name must not be default. Okay. And second one, we are going to configure IP domain name. Third one, we are going to generate crypto RSA keys. And then we are going to configure user name and password. And then we have configure VTY lines. Okay, these are the conditions in your SSH. But in Telnet, directly you can go to configure VTY lines. Just say line VTY 0 to 5, password 1 to 3, login. That's it. But in SSH, we have to match all the conditions. Written, guys. I'll take another router. I'll change everything. Host name, I'm going to change it to SSH. Okay, simply I'll change like that. Any name you can change, just not router. Okay, that's it. After that, IP address is there. What is the IP I've given here? 1.1.1.1. Sure. Okay. Here I will give 1.1.1.20. Why? Now it is pinging. Here also it is pinging. Okay. See, when router pings 5 packets, when PC pings 4 packets. Okay. Now I'll do the configuration of SSH. First, I'm going to change the IP host name. I've changed the host name. Second one is what? Domain name. So I'll say IP domain name. I'll say cisco.com. Okay. And then I'm going to create the cryptographic keys. Okay. For that, I'm going to say crypto key RSA. Generate RSA generate keys. That means I'm going to create a cryptographic keys. RSA means it's an algorithm. Okay. So this cryptography, RSA, these things and all you will learn in detail in your VPN. Okay. What is going to do? It is going to exchange a public key, and through that public key, they will exchange the information. That is, I'm this key, I have my public key. I will share you my public key. Okay. The router will share the public key to the PC so that they will know, okay, he is the correct person who is sending me the key. And if he wants to send any data, he will encrypt to the public key and send it to the router. Okay, it is totally a VPN concept, but as of now, understand cryptography keys is used to encrypt the data. Okay, key generate, and then you have modulus crypto key generate RSA generate key modulus. How many bit I have to encrypt it? So I'll give 2048. Enter. Okay, see here you can see SSH is enabled. Now, first initially I changed the host name, and then I've created a domain name. Third one, I've created a cryptographic keys. Now I will create the username and password. Username, I will say CCIE. Okay. Privilege, I will give 15. Complete privilege, I will give. Okay. And then password, I will say 123. Enter. Okay. Now what username is created? Now I have to create the line VTY lines. So I'll say line VTY 0 to 5. Okay. And then I will say login local because username is created. Okay. And I'll say transport input SSH. I mean, this means you put all this information on the line 0 to 5. Whatever created on the SSH, put it on the line 0 to 5. That means transport input SSH. Okay. Now what I'll do, I'll go to this PC. Already I've checked the connectivity, correct? Check the connectivity is done. So to get the access of SSH, you have to say SSH -L. What is the username? CCIE 1.1.1.20. Correct? Give enter. It is asking for password. Go to simulation. Edit filters. Here you have SSH. Capture SSH. Password is 123. So 3 packets are generated. Click on this packet. Go to outbound PDU details. See, encrypted data. Next packet, encrypted data. Next packet, encrypted data. So you can't see the password because we have added more secure to that. That means we have created IP domain name. Inside the domain name, we have created the RSA keys. That means cryptographic keys we have generated and asked it to encrypt it in 2048 bit. That is more secure. So that it will be secured. Only the person who has intent to see, only they can see it. Okay. Now close this. Come to real time. Click here. Now you got the password 123. Enter. Now you got SSH. I can go to configure terminal. Do show IP. Interface brief. Now I can see this. I can configure the 0/C also. The 2. I can make no shutdown. Okay. Now see again. Changes stated to up 0/2. Likewise, I can completely do all the practicals of SSH. I mean the router, SSH router. And it is a secure channel. So we are not preferring Telnet for different network. Within a network they do, but not in different network. Why? Because the data is in plain text. Here it is encrypted. Okay. Any doubt on this? No. Okay. I'll give you the commands. You can write it down. See the key, the name for the keys will be sshcisco.com. And it is in 2048 bit. It will encrypt the data. Okay. How many of you are here for CCIE? Raise your hands. Tall. 1, 2, 3, 4, 5. Okay. Oh. Okay, write it down. How to get access? SSH -L and then username, and then IP address 1.1.1.20. Here you have to change the host name also. Okay. The router, it will be host name. Sorry. Host name, change it to SSH. The conditions should match. How many of you are using Geo network here? Is it speed? It's very bad, no? Just not here. In general. Oh God, sometimes I eat something. I try to pay, I will not be able to pay. Very embarrassing it is. Even today it happened. Huh?
5G not support completely, but 4G supports.
Exactly. I see few people are missing classes. I know two people have called and said me saying that, sir, I'm not feeling well, I'm doing online. See, that is fine. If you have the privilege of coming to class, that means if you're staying in Bangalore, I can come to class, better come to class. Because the difference is not there. But it's good to come and sit in class and study. Okay. Because usually what will happen first 2 weeks, people are coming offline. Then they will take it granted and they will go to online class. Don't take CCNA lightly. Very important. How many of you are attending communication classes? 1, 2, 3. You also? 4. Good. If you feel like I'm not much good in the communication, better join it. Okay. Try to speak more so that after 2, 3 months, you'll be able to communicate it. Written, guys? Okay.
Yes,
Now,
sir.
okay. Come to the PPT. Here your SSH. So, SSH is cryptographic network protocol for operating network services securely over a unsecured network. So typically applications include remote command line, login and remote command execution, but any network service can be secured with SSH. Okay. So SSH provides a secure channel over an unsecured network by using a client server architecture, same as your Telnet. So the remote system will be acting as the server and you will be acting as the local computer will act as the client. Okay. And application with SSH server, the protocol specification distribution between two major versions. We have SSH version 1 and 2. So the bit which is used for encryption is more secure in your version 2. Okay. And SSH was designed as the replacement for Telnet and for unsecured remote shell protocols. Okay. So it has replaced the Telnet completely by giving the secure channel. Okay. So what are the key points? It is also application layer protocol used for remote access in secure way. uses port number 22 by default. And then TCP protocol, encrypted format to send the data, and also uses a secure channel. All this is because of the conditions we matched. We have created the domain name, RSA keys, and then 2048 bit to encrypt it, and then username, and then SSH. So all these things will match and they will exchange the keys accordingly. It is more secure. Okay. And then SSH helps you to overcome many security threats issued by Telnet. It is more secure protocol, uses public key encryption for authentication, require high bandwidth. Why high bandwidth means? Multiple things are there. So that's why high bandwidth. Used in all popular operating systems. Okay. And these are the key differences. You can say it and write it later. Okay. Any doubt on Telnet SSH? No. So today you have four practicals. We have seen ICMP, ARP, proxy ARP, Telnet SSH. 5 topics we have seen today. Correct? So ICMP is like a more of a theory, but in ARP there is small practicals. Proxy ARP again another practicals you have. Telnet do the practical and also SSH. Do all 4 practicals, see the recording. Today's class is very important. It's your basics. Okay. If you understand this only, you will know how a packet travels in different networks. If you don't understand this, simply you will do the practical. Just copy paste the comments, that is fine. But in interview, you will get caught. You will have issues. So understand the concept, do the practical. If you have any doubt, come back to me. Okay. Anything else? No. Online guys, all clear? Any doubt?
No, sir.
No. All good. All right. So I'll see you guys tomorrow. Thank you very much. Don't disconnect, wait.